Here are two things that are really important when interpreting the slope and the y-intercept of our regression equation. And so this is something I want you to highlight in your notes and make sure you put on your formula card. Above we have kind of the formula for calculating the slope and the y-intercept. Again, your technology will do that for you, but know that the slope has to do with the correlation coefficient times the standard deviation of the y variable divided by the standard deviation of the x variable. And for the y-intercept, one of the points on that line is actually the mean of the x values and the mean of the y values. So that's kind of where the y-intercept formula comes from. But more important than understanding how to calculate this line would be to interpret it. And so this is very important, looking at our slope over here, which is for every 1 unit of x increase in our x variable, the y variable is predicted to increase or decrease by whatever our slope is, and then the units of y. So if we're comparing the height with the foot length, we would say for every 1 inch increase in our height, our foot length is predicted to increase by whatever our slope is, and then units, we don't usually have like units for our shoe size. Y-intercept, on the other hand, tells us what happens when x is equal to 0. So again, for an x variable of 0 and then put in your units, we should predict that the y variable to be whatever our y-intercept is, and then put in the units of y. So this will make more sense in the context of a question. So we're going to go down to exercise 2 and look at the following example. So just like before, we have the linear regression of systolic blood pressure versus weight. We have our regression equation, which was given as 1.1 plus 0.764 times x, where x was the weight and y was the systolic blood pressure. So for our interpretation, we have the interpretation for the slope, which tells us what happens as x increases by 1. So for every 1 unit, so 1 pound increase in weight, the systolic blood pressure is predicted to increase by, and then we look at our slope, which is 0.764. No matter which order this is written in, our slope is always right in front of the x, by 0.764, and then our units for y are millimeter mercury. So for every 1 pound increase in weight, the systolic blood pressure is predicted to increase by 0.764 millimeter of mercury. Our y-intercept says what happens when x is equal to 0. So for a weight of 0 pounds, we would predict the y variable, which is the systolic blood pressure, to be 1.1 millimeter of mercury. And over here, one thing to note is there's no one walking around with a weight of 0 pounds. So really, oftentimes this is meaningless because it's looking outside of the scope of our data. Again, there's no one walking around who doesn't weigh anything, and there's no one with a systolic blood pressure of 1.1 millimeter of mercury. So make sure in the context to consider whether the y-intercept makes sense or not. Oftentimes it does not make sense.